How's it going, everyone? This is Mr. Hobbig. We're going to learn about triangles today. Very exciting. Love triangles. They're probably my favorite shape. I'm going to go out on a limb. Three angles, three sides. What's not to love? So today we're going to talk about triangles. Get your notes ready. I'm not going to know if you're going crazy. So try to stay quiet so that people can hear the video. Okay, here we go. So, day one of triangles. A triangle. Let's make this tighter. Sorry, you guys are seeing it live right now. Boom, way better. A triangle is a polygon with three sides. Triangles can be classified by their sides or their angles. There's three of each, right? On a triangle. Try three, like a tricycle. Okay, so the sides are, start with AB. Now these are line segments. So we're going to name them as line segments. You got BC. And then you got CA. Okay. The vertices are basically the corners. So these little guys here. Okay, so the vertices are A, B, and C. All right, so first let's try to classify our triangles based on the angle measurements. Gotta scoot it up over my head. So first we got, get out of here. First we got this guy. This is three acute angles. Remember, we're looking at angles. So three acute angles makes an acute triangle. So once again, acute is angles that are less than 90 degrees. So there's three of them here. So you have all angles are acute. Less than 90 degrees. Okay. This is three congruent angles. It's called equiangular or equiangular. Equal angle. Euler. Let's make this look nice. Equiangular. And since they're all congruent, that's what this little guy means. Right? That means that they're all going to be 60 degrees. But I'm just going to put three congruent angles. Spoiler alert, they're all 60 degrees. Okay, now let's go over here. Looks like we have a right angle here, guys. We got a right angle. That makes a right triangle. That's probably one you knew already. A right triangle has one 90-degree angle. Okay, and this, let's say this is an obtuse angle. Well, if you have an obtuse angle, that means you have an, if you can see, acute, right, obtuse triangle. Are you even having to remember anything here? An obtuse triangle has one obtuse angle. Easy peasy. So let's do some work. So just once again, you got one acute, or you got all acute angles. It's an acute triangle. If you have a right angle, it's a right triangle. If you have one obtuse angle, it's an obtuse triangle. If they're all congruent, you got an equiangular triangle. Here we go. So we're going to classify each triangle here. Let's look at them. So EHG, So you draw it like you named it. Okay? What does that mean? Use your little pointer here. E to the H to the G. Okay, so that's the whole big triangle. Well, in the whole big triangle, I got this little guy, this little right angle. So it's going to make this a right triangle. This is a symbol for triangle. E, F, H, E to the F to the H. Boom, 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 boom. I got a 30 and a 30, but what's this angle? Can you tell just by looking at it? Probably looks kind of obtuse, but how would we know for sure? Well, this is a linear pair here, which means if I were to add those angles together, it would equal 180 degrees. So if this is 60, the whole thing's 180. Then real quick, 180 minus 60 is going to give me 120. So this is 120 degrees. What does that mean? Well, that's a obtuse angle. So this is an obtuse triangle. Hold on, dude. Then you got FHG. So here's F, here's H, here's G. Hey, I need you to be quiet, okay? Love you, big girl.
I'm in Dad over here.
Thanks for being quiet. FHG. This is 60, this is 60, this is 60. How do I know? I just know. If this is 30 of the 90, then this is the other 60. So this is an equiangular triangle. All equiangular triangles are also acute triangles. How do I know it's 60? Okay. Well, if this is 90, we can use angle addition. 90 minus 30 is equal to 60. Because this one is 60, look, they're all 60. So these are all congruent to each other. Okay? Okay. Congruent angles. I don't know if you guys could hear my kid. I'm sure you did. She's not a quiet girl. That's okay. Okay, let's look over here. Triangle classifications by side length now. Oh, geez. These are probably going to be some familiar names. So this is, if you look at them, it's all about what sides are congruent. How many congruent sides do we have? This one, none of the sides are congruent. It's called a scalene triangle. Scalene triangle has no congruent sides. Okay. This one has two congruent sides, often called legs, and one base. It's called an isosceles. Isosceles. Isosceles triangle has two congruent sides. The two congruent sides are called legs. How do we want to say this? Let's kind of make a cool arrow like this. Boop, boop. Legs. And then this guy right here is called the base. Two congruent sides called legs. Okay, isosceles triangle. Two congruent sides. This one has all congruent sides. Do you know what this one's called? All together, class. Equilateral. Good job. It's an equilateral triangle. It has three congruent sides. Okay, so we're just classifying by size. So classified by angles or classifying by sides. Classify each triangle by its side lengths. Okay, so ABC, A, B, C. Boom. That's this triangle right here. Looks like we got 1, 2, 3 congruent sides. What's 3 congruent sides, guys? Let's look back up here. It's an equilateral triangle. Duh. We just talked about that. Don't you remember? Weren't you listening? What about ABD? What about ABD? Well, AB's 15. AD's 18. Did you think just because this mark was here that it was congruent to this AB? No, that's BC. BD is 20, so none of them are congruent. That's going to make it scalene. Mr. Hobbig, there's 2 congruent sides, the AB and the B. No, you add 15 and 5 together, you get 20. So it's 15, 20, and 18. So no, there was no congruent sides there. What about EHF? EHF. 1, 2 congruent sides. What's the length of HF? Can you tell me? It's isosceles. Length of HF, if it's congruent to EF, that means this one's 10. The legs are 10 and the base is 12 on my isosceles or isosceles triangle. Okay, let's move forward. I hope you got a little extra time. 3, 2, 1. Here we go. We're going to find LK. Let's start sprinkling our algebra in here. Okay, LK, it's right here. Okay, what else do I know? How the heck am I going to solve for x? I need an equation here. I need 2 things to be equal. Is anything equal to LK? Why, yes, Mr. Hobbig. JK is equal to LK. Hey, good idea. LK is equal to JK. So let's substitute in LK. Okay. LK. That's x plus 3.2. And that's going to be equal to whatever the heck JK is. Let's come down here to our picture. Oh, there it is. It's 4x minus 1.3. Hey, we're doing algebra now. Huzzah. I've sprinkled algebra into your geometry. Now it's time to suffer. Okay. So, you should already be done with this. I'm giving you guys time so you can finish it, and then you can check your algebra against what I'm doing. Make sure you're doing it. So I'm going to start by subtracting x on both sides. Why did I subtract x from both sides? It was to get rid of this area. Okay? So that's going to give me 3.2 on this side. Here's some math I got to do. There's 3 x's there now. I didn't do anything to the 1.3. Okay, step 2. I'm going to add 1.3. You should have already done this. You're probably like, oh my god, why does it take so long? To prevent you from going to the restroom. That's why I'm taking so long. Strictly to hurt you. Alright. I'm just a bitter guy. Let's add these together. That's going to be 4.5 is equal to 3x. You're probably like, gosh, we get it. X. Oh my god, hurry. Okay, so I'm running out of room here, guys. I'm a little concerned. Probably should have made this smaller. I didn't. We're here now. So we're going to divide this by 3, and we're going to divide this by 3. Ooh, it's getting tight. And then x is going to be... What's 4.5 divided by 3, guys? It's 1.5? Okay, so if x is 1.5, are we done? Are we done? Guys, are we done? No, we're not done. We're trying to find LK. So LK is this one. But you could really plug it into either one because they're congruent. So you get to pick there. So LK is this, so it's going to be 1.5 plus 3.2. What's that going to be? 4.7. Whee! All right, I stole some room from this one, so we're going to kind of cheat a little bit. Look at that. You guys are like, what? Who's this guy? Who's this wizard? We're going to make it, we're going to blow it up. Let's blow it up, y'all. All right. FGH. Oh, scoot it over a little bit. There we go. FGH. Find y on the equilateral triangle. Well, equilateral triangles, ooh, what does that mean? How can we set up an equation to find y? Things got to be equal, right? So let's set two things equal. These numbers look smaller. Let's use those. 3y minus 4 is equal to 2y plus 3. Okay. Are you already done? Did you finish this already? Oh my god. Oh. I'm going to subtract 2y from both sides. You should already have done that. I hope you didn't wait for me to do it. Oh my gosh. Can you imagine just wasting your time sitting there waiting for me to do something? So that's going to cancel those out. You end up with 1y minus 4 equals 3. I meant to switch back to purple. I didn't. I'm sticking with the decision. Now we're going to switch back to purple. So confusing. I'm going to add 4 to both sides. Did you get it yet? What's y? Did you do 3 plus 4 yet? Or did you wait for me to write what 3 plus 4 is? Just do it ahead of me so you can get the mistake done and then correct it. Check your stuff on my stuff. Look how much nicer that is over there. We're going to do that from now on for sure. Okay. Now we're going to get some theorems here. How about let me give you guys a chance here. The sum of the angle measures of a triangle is 180 degrees. What? Is that true? Yes. So all my angles are going to be 180 degrees. The measurement of angle A plus the measurement of angle B plus the measurement of angle C is equal to 180 degrees. Every triangle is like that. So if you have two angles, figure out the third. Just subtract them both from 180, you'll get the third angle. Okay? So we're going to use the diagram to find the angle measurements. Okay, so they did a bunch of wonky triangles over here. Let's see if we can suss through this stuff. Oh my gosh. What's the measurement of NKM? Remember, the vertex is that middle letter. So let's draw it out as we say it. N. Okay, let's use our highlighter. N to the K to the M. Okay, so that's this angle. How would I find that angle? I only have these two. How would I know the third? Right, we're going to subtract them both from 180. So it's going to be this equation right here is going to be, how would you want me to do this? I don't know. I'm going to write this equation right here. This is what I know, so I'm going to write it. So the measurement of angle N is 48 degrees, plus the measurement of angle M is 88 degrees, plus the other one, I don't know it yet. Let's call it O. How do you guys feel about theta? This is a fun little variable, often used to talk about angles. Basically an x. It's the same thing. So I'm going to call it theta because that's cool. That's going to be equal to the 180 degrees. I'm just rewriting my triangle sum theorem, substituting in the other two angles. Add those together and you end up with 136 plus theta is equal to 180. If this is confusing, just write x. This means x. If you just hate my Greek letter theta, you can write x. It's fine. Okay. So, subtract the 136 from both sides. Okay. Okay. So theta is equal to boom, 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 44 degrees. Okay. This one's 44. This picture is not the best, but that's okay. All right, so this one's gonna be 44 degrees. Maybe put the 88 over here next time. I don't know. All right, what about JLK? So here's the J, here's the L, here's the K. Uh-oh, they're gonna trick us here. Look at this. Look at this. Look at these guys. You guys. Okay, this is a little tricky. Why? Why is this tricky? Well, JLK's this one. Right? Let's call this one X. We'll call this one X. If this is X, I need to know this angle over here. I got the 70, but I don't know what this one is. However, I just found out this is 44 degrees. If this is 44 and this is 104, you can find this one because this is a straight line. It's kind of like three angles that make a straight angle. It's kind of like that. Or maybe a linear trio, if you will. Can we call it that? I don't know. I don't think that's an official terminology. But we're going to add this one and this one. We're going to subtract it from 180. So 44 plus 104. How do you guys feel about me doing this? What's that going to be? How do you feel about this? It's just another way to do it. There's another way to do this too. You know what's interesting? If I show you the cool way. No. I should show you the cool way. This 44 and this 104 is equal to the 70 plus this, which is interesting. Is it? Yes. I'm not going to do it. But you could do it, but I'm not going to do it. Okay, so all three of these is going to be 180. Maybe I'll show you what I mean after I do it. So if 104 plus 44, if you subtract that from 180, so I'm just going to rewrite the same thing. Sorry if you erased it. What's this going to be? Well, that's 148. And that's going to be 32 degrees. Okay, so this is 32. Okay, now I can find my X over here. It's pretty much the same thing. This is this, if you couldn't tell. Let's do it the same way. Okay, so we're going to do our triangle sum theorem. One angle. I'm going to do the X as the first one. Plus the other two angles, plus the 32, plus the 70. It's all going to equal 180 degrees. Add those together. And subtract the 102. You're going to get 78. Okay, 78's the answer. It's too far gone for me to show you, but if I would have set this up like this one, you would have seen that these two things are both equal to 180, and you could just like set them equal to each other. It's kind of interesting. Oh well. Exterior angle theorem. I hope you guys got this. 78 degrees, 44. I taught that so bad. This problem's kind of interesting. Okay, here we go. A remote interior angle. Oh, these are so cool. A remote interior angle is an interior angle that is not adjacent to the specified exterior angle. What the heck does that mean? Good question. So an exterior angle is the angle that's made on the outside of the shape. So over here, angle 4 is the exterior angle. See how it's kind of made by the shape? If you extend this side out, let me get this. If you extend this side out, and see how it makes an angle right here? It's made by the shape, sort of. It is made by the shape. So if you didn't notice, 3 and 4 are a supplementary linear pair. So they're going to add up to equal 180. Well, what else adds up to equal 180? All 3 angles in a triangle. So the remote interior angles are the interior angles that aren't next to the 4. So that's going to be angle 1 and angle 2. I guess number 2 is remote interior. Not too sure what's supposed to go here. But 1 and 2 are the remote interior angles. 4 is the exterior angle. Okay. And it turns out angle 4 is equal to angle 1 plus angle 2. You should put M's here. Okay. Remote interior. This is an N. And this is a remote exterior. No, it's just an exterior angle, not a remote. Exterior angle. Okay. Now they're remote interior angles because they're not next to the exterior angle. That's the only thing. That's the reason why they're remote. So another way that I've heard it described is like, where's the remote for your TV? Well, it's never next to you. It's never next to you. Let's say you're an exterior angle. The remote is not next to you. Okay, so we're going to find the measurement of angle J. Here's angle J. What do we really need? We need to find X. If I don't know what X is, I'm never going to know what angle J is. So we're going to use, guess what? The exterior angle theorem. Here's the exterior angle theorem. The measurement of angle FGH, the exterior angle here, is equal to the measurement of the remote interior angles. Okay. So now we just substitute in. FGH is 126. Is equal to the measurement of H. Come over to H. There it is. 6x minus 1. Ooh, excuse me. And then plus from the equation, measurement of angle J. That's over here. 5x plus 17. All right, we're combining like terms. We're doing algebra again. Let's switch to black. I feel like black just looks better. Let's scroll up a bit. Okay. Let's combine like terms. 126 isn't changing. I got 6 x's. I got 5 x's. I got 6 apples and 5 apples. That's 11 apples. Then I got -1 orange and 17 oranges. Well, that's 16 oranges. Now what? Find x. We're going to subtract 16 from both sides. you end up with, I'm trying to let you guys do it ahead of me right now. 110 is equal to 11x. Why did we subtract 16? To get rid of this. Okay. And you're going to divide by 11. Divide both sides by 11. You can't just divide one side. Why did I do that? Well, that gets rid of this. Okay, I hope that makes sense. It should make sense by now. 10 is equal to x. All right, we did it. No, you thought we did it. You fool! We're finding the measurement of angle J. That's over here. Well, the measurement of angle J is 5x plus 17. Well, now I know what x is. So instead of x, I'm going to write what x is. 5 times 10 plus 17 is going to equal, that's 50 plus 17. 67 degrees. Does that make sense? That's my x right there. All right, hope that made sense. Let's move forward. Oh, this is the end. Oh, no, it isn't. Yes, it is. Oh, but you guys can't see it. Oh, geez. Okay, that's better. That's better-ish. One moment, please. Sorry for the... What is going on? Why is this so hard to do? There it is. Okay. Okay, third angle theorem. So this one says if you have two pairs of congruent angles in a triangle, then that means the other angles will also be congruent. That means this is true. N and T will be congruent. So once again, L and R are congruent, M and S are congruent. So that means these other two angles have to be congruent, which makes sense, right? If this was 30 and this was 60, this one would be 90. If this was 30 and this was 60, this one would be 90. Okay, so we're going to use that to kind of prove this crap. So right angles are always congruent, and A and D are congruent. So that means, guess what else is congruent? C and F. So if they're congruent, then we can say they're congruent and we can say they're equal. The measurement of angle F is equal to the measurement of angle C. So we just substitute in our values. C was y. F was 3y minus 72. Uh-oh. Nah, that's not bad. Okay. I thought I was a little worried. Got a little worried there for a second. Okay, so we're going to subtract. It's because I can't do math. That's why I was worried. Minus 3y from both sides. Why am I doing minus 3y? Mr. Hobbig, you like to keep things positive. You like it when they're positive. I do. I don't know why I did that. But this is going to help me save a step. You can either believe me or not. All right, so this cancels out to negative 72 is equal to negative 2y. And then we divide by negative 2. Can you still see? Yes, you can. What's y? What's y going to be? Have you figured it out yet? Y is equal to 36. It's positive too. Okay. Well, angle C is 36, but what would angle F be? If you didn't instantly say 36, come on now. They're equal to each other. That was the whole point. All right, so that's the end of this lesson. Guided practice time. Who's excited? I see you back there. Wow, you're excited. Jeez, put your hand down. Oh my gosh. How excited are you? Ideally, you have the assignment by now. I'm going to let whoever pause it or whatever start the assignment in 5, 4, 3, 2, 1. Okay. A jeweler creates them by bending pieces of silver wire, creating an isosceles triangle with the dimensions shown. I guess them is implying these earrings. How many earrings can be made from a piece of wire that is 50 centimeters long? Jeez. Okay. So, in order to answer this question, I need to know how much wire I need per earring. Makes sense? I have 50 centimeters. How much wire do I need? Well, how the heck would I know that? I only have this side right here. And I got this side. I need to know what this side is. How would I know that? Well, isosceles is how I know it. Okay, let's assume that these are the congruent sides, just because that's how it looks on the picture. So we're going to say this is actually 3 centimeters. Isosceles has 2 congruent sides. So we need the perimeter of this thing. Perimeter is the length of all 3 sides. 3 plus 3 plus 1.5. That'll be 6, and 1.5 is 7.5. Okay. Now I have 7.5 is 1. I got 50 centimeters. How many can I make? Well, you do 50 divided by 7.5. What's that going to be? I have no idea. I know it's going to go to 45. So that's going to be like 6, I think. Yeah, it'll be 6 and a bit. So this is going to be 6.67. Isn't that funny? And then that'll give you, well, obviously I can't make 2/3 of an earring and sell it. I'll probably sell it to one of you, but that would be rude. So it's going to be 6 earrings. 6, 7, somewhere in that area. Oh my gosh. It's so funny to me. All right, so we're going to solve for y on the other one. Okay. It's stars with y's. All right, here we go. Very exciting. All right. So what the heck? There's nothing's congruent. Nothing's what? How would I solve for this? All I know is that there's 3 angles in a triangle. What do I know about 3 angles on a triangle? That's right. They all add up to 180 degrees. So the measurement of angle D for the Deneb system, the Deneb star cluster, plus the measurement of angle V for Vega, plus the measurement of angle A for Altair is going to equal 180 degrees, even when it's in the stars, guys. It's true. Substitute in all this junk. D is coming over here, 3y plus 13 plus, from the equation, V. Where's Vega? There it is. 5y minus 5 plus measurement of angle A. Where's angle A? There it is. It's 2y plus 2. And that's all going to be equal to 180 degrees. Wow. Look at all these terms. What do I do? Guys. Just group your like terms. Where's my y's? There's my y's. Here's my numbers. Here's my numbers. Okay, so you're just adding up the apples and adding up your oranges. If I had three apples and 13 oranges, would I have 16 oranges? No, they'd be separate. So that's how you treat the y's and the numbers. So let's combine our like terms. I got 3y's, 5y's, 2y's. That's 10 whole y's. Plus, I got 13 minus 5 plus 2. That's 10. Oh, all of a sudden it doesn't look so hard, does it? You guys were freaking out. Chill out. Holy smokes. Subtract 10 from both sides. Did you already finish this? Uh-oh. Why did I subtract 10? Just to get rid of this 10. That's why I subtracted 10. You fool. It's going to be 170. Okay. Did you already divide it? Did you already divide it? Do you know already? You should know. Did you use a calculator for this? Surely not. What's 170 divided by 10? Well, it turns out it's 17. Okay. We did it. That's the end of it. We did it, guys. Oh my gosh, look, I was hiding that from you. My bad. There you go. Did you get that one? I appreciate y'all learning about, what did we talk about? You can classify your triangles by the angles, classify it by the sides. Isosceles, 2 congruent sides. Equilaterals, 3 congruent sides. Acute triangle, a right triangle, obtuse triangle. It's all the angles. What else did we learn? Remote interior angles? Oof, that's the tricky one. Can you do this one right here? This is remote interior right here. This one, just a quick this Easter egg. You stayed after the credits. This one right here is equal to this one plus this one. All right, that's all I'm saying. That's the only one you get. All right, thanks for watching, y'all. You guys have an excellent rest of your day. Get your assignment done right now. Don't wait. Don't look over at anyone else. Finish your assignment. Math is all that matters. You guys have a good day.